According to the National Electrical Code, specifically Section 330.30, metal-clad cable shall be terminated with fittings approved for the purpose. One of the most common types of fittings used to terminate metal-clad cable is an anti-short bushing. This bushing is designed to prevent accidental contact between the live conductors and the metal sheath of the cable, which could cause a short circuit. The purpose of an anti-short bushing is to provide an insulating barrier between the conductors inside the metal-clad cable and the sharp edge of the cut metal jacket. Without this bushing, the conductors could rub against the metal jacket over time, especially with movement or vibration. This rubbing action can wear away the insulation on the conductors, eventually leading to a short circuit. A short circuit can cause a variety of problems, including blown fuses or circuit breakers, electrical fires, and even electric shock. Therefore, it is essential to use anti-short bushings when terminating metal-clad cable to prevent these hazards. The fact that metal-clad cable comes with a ground wire does not negate the need for an anti-short bushing. The ground wire is designed to provide a path for fault currents back to the source in the event of a ground fault. A ground fault occurs when a live conductor comes into contact with a grounded surface, such as the metal enclosure of an appliance or piece of equipment. The ground wire provides a low impedance path for the fault current, which causes the circuit breaker or fuse to trip, interrupting the flow of electricity and preventing a dangerous shock hazard. However, the ground wire does not protect against accidental contact between the live conductors and the metal sheath of the cable. This is because the ground wire is typically connected to the metal sheath at the electrical panel, not at the point where the conductors exit the cable. Therefore, if a live conductor comes into contact with the metal sheath at the termination point, there is no direct path for the fault current to flow back to the source. This means that the circuit breaker or fuse may not trip, and a dangerous shock hazard could exist. Inspectors have the right to require the installation of anti-short bushings on metal-clad cable terminations in order to ensure the safety of the electrical system. Inspectors are responsible for enforcing the National Electrical Code and other applicable electrical codes. They have the authority to require that electrical installations meet certain safety standards in order to protect people and property from electrical hazards. The requirement to install anti-short bushings on metal-clad cable terminations is a well-established safety standard that has been in place for many years. Inspectors are simply enforcing this requirement to ensure that electrical systems are installed safely and correctly. The metal-clad cable provides a degree of mechanical protection to the conductors inside. It is a spiral wound metal jacket, and inside this jacket are insulated conductors along with a bonding strip, which serves as the equipment grounding conductor. The cable is typically used in situations where the wiring needs to be protected from physical damage or exposure to moisture or other environmental factors. Proper installation of metal-clad cable involves several steps. Firstly, cutting the cable to the desired length using an appropriate cable cutter. Secondly, after cutting, carefully remove the outer jacket of the cable to expose the insulated conductors inside. Be cautious not to damage the insulation on the conductors. Thirdly, slide an anti-short bushing over the exposed conductors and into the end of the metal-clad cable jacket. This bushing protects the conductors from abrasion against the cut edge of the metal jacket. Fourthly, insert the cable and conductors into the appropriate fitting or connector at the electrical box or equipment. Secure the fitting tightly to ensure a good mechanical and electrical connection. Fifthly, properly terminate the insulated conductors to the appropriate terminals or devices inside the electrical box or equipment, following all applicable electrical codes and standards. The anti-short bushing is a crucial component in ensuring the safe and reliable operation of electrical systems using metal-clad cable. The metal jacket of the metal-clad cable provides a path for ground fault current, helping to quickly trip a circuit breaker or fuse in the event of a fault. The equipment grounding conductor, or bonding strip, inside the cable provides an additional path for ground fault current and helps to equalize the potential between metal parts of the electrical system. This reduces the risk of electric shock. There are different types of fittings available for terminating metal-clad cable, including connectors for attaching the cable to electrical boxes, couplings for joining two lengths of cable, and adapters for connecting the cable to other types of wiring systems. When selecting fittings, it is important to choose those that are specifically designed for use with metal-clad cable and that are approved by a recognized testing laboratory, such as Underwriters Laboratories, or ALL. Always follow the manufacturer's instructions for installing fittings to ensure a proper and safe connection. When working with electrical wiring, it is essential to follow all applicable electrical codes and standards, such as the National Electrical Code, or NEC. These codes provide detailed requirements for the safe installation of electrical systems and equipment. It is also important to wear appropriate personal protective equipment, such as safety glasses and gloves, to protect yourself from electrical hazards. Working with electricity can be dangerous, and it is important to take all necessary precautions to ensure your safety and the safety of others. In summary, anti-short bushings are required for terminating metal-clad cable, regardless of the presence of a ground wire. They are a critical safety component that prevent short circuits and electrical hazards. Inspectors have the authority to enforce this requirement to ensure the safety of electrical installations. Always follow electrical codes and standards and use appropriate personal protective equipment when working with electricity. Proper installation of metal-clad cable and the use of anti-short bushings are essential for ensuring the safe and reliable operation of electrical systems. Metal-clad cable offers advantages in certain applications, such as providing better protection against physical damage compared to non-metallic sheath cable. It is also suitable for use in exposed locations where wiring might be subject to mechanical stress. However, metal-clad cable can be more challenging to install than other types of wiring due to the need for specialized tools and fittings. It is important to have proper training and experience before working with metal-clad cable to ensure a safe and code-compliant installation. In addition to preventing short circuits, anti-short bushings also help to protect the conductors from damage during installation. When pulling metal-clad cable through walls or ceilings, the conductors can be easily damaged if they rub against the sharp edge of the metal jacket. The anti-short bushing provides a smooth, rounded surface that prevents this damage, ensuring the integrity of the wiring system. Some types of metal-clad cable are designed for specific applications, such as healthcare facilities or hazardous locations. These cables may have additional features, such as a continuous aluminum armor or a gas-tight jacket, to meet the unique requirements of these environments. It is important to select the appropriate type of metal-clad cable for the specific application to ensure safety and compliance with electrical codes. Regular inspection and maintenance of electrical systems are essential for identifying and addressing potential problems before they become hazardous. This includes checking metal-clad cable terminations for any signs of damage or wear, such as loose fittings, cracked bushings, or damaged conductors. Any issues should be repaired promptly by a qualified electrician to prevent electrical hazards. When making connections in electrical boxes, it is important to ensure that all conductors are properly tightened and secured. Loose connections can cause arcing, which can generate heat and lead to electrical fires. Use appropriate tools, such as torque screwdrivers, to tighten connections to the manufacturer's specified torque value. This ensures a reliable and safe electrical connection. The National Electrical Code is updated every 3 years to reflect changes in technology and best practices. It is important for electricians and other electrical professionals to stay up to date on the latest code requirements to ensure that their work is compliant and safe. Continuing education courses and industry publications are valuable resources for staying informed about changes to the National Electrical Code. Proper grounding is essential for electrical safety. The grounding system provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Ensure that all metal parts of the electrical system, including metal-clad cable jackets, are properly grounded in accordance with the National Electrical Code. Surge protection devices, or SPDs, can help to protect electrical equipment from damage caused by voltage surges or spikes. These devices are typically installed at the electrical panel and can divert surge current away from sensitive electronic equipment. Consider installing SPD to protect valuable equipment from damage caused by power surges. Arc fault circuit interrupters, or ARCs, are designed to detect arc faults, which are a common cause of electrical fires. ARCs can detect both series arcs, which occur in a single conductor, and parallel arcs, which occur between two conductors. These devices are required in many areas of the home, such as bedrooms and living rooms, to provide enhanced protection against electrical fires. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock. These devices detect ground faults, which occur when current leaks from a circuit to ground. GFCIs quickly interrupt the flow of electricity, preventing a dangerous shock hazard. They are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. When working with electrical wiring, it is important to energize the circuit before starting any work. Use a voltage tester to verify that the circuit is energized before touching any wires. This is a critical safety precaution that can prevent electrical shock. Lockout-tagout procedures are used to prevent accidental energization of electrical circuits during maintenance or repair work. These procedures involve locking the circuit breaker in the off position and tagging it with a warning sign to prevent someone from accidentally turning it on. Lockout-tagout procedures are essential for ensuring the safety of electrical workers. Electrical safety audits can help to identify potential electrical hazards and ensure that electrical systems are in compliance with safety standards. These audits are typically conducted by qualified electrical professionals and can help to prevent electrical accidents and injuries. Regular electrical inspections are important for identifying and addressing potential problems before they become hazardous. Schedule regular inspections with a qualified electrical inspector to ensure that your electrical system is safe and code compliant. Education and training are essential for preventing electrical accidents and injuries. Provide employees with regular training on electrical safety topics, such as lockout-tagout procedures, personal protective equipment, and safe work practices. Informed workers are more likely to follow safety procedures and avoid electrical hazards. The information provided here is for general informational purposes only and should not be considered as a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work or concerns. Improper electrical work can be dangerous and can lead to serious injuries or property damage. Metal-clad cable is available in different sizes and configurations to meet the needs of various electrical applications. The size of the cable is determined by the ampacity of the conductors inside, which must be sufficient to carry the load of the circuit. The configuration of the cable refers to the number of conductors and their arrangement within the cable. When selecting metal-clad cable, it is important to choose the appropriate size and configuration for the specific application. Improperly sized or configured cable can lead to overheating, voltage drop, and other electrical problems. Metal-clad cable is typically installed in accordance with the National Electrical Code, which provides detailed requirements for the installation of electrical wiring systems. The code covers topics such as cable support, protection from physical damage, and proper termination methods. It is important to follow the National Electrical Code when installing metal-clad cable to ensure a safe and code-compliant installation. There are various types of connectors available for terminating metal-clad cable, including compression connectors, set-screw connectors, and snap-in connectors. The type of connector used will depend on the size and type of cable, as well as the specific application. It is important to choose connectors that are specifically designed for use with metal-clad cable and that are approved by a recognized testing laboratory, such as Underwriters Laboratories. When installing metal-clad cable, it is important to avoid sharp bends or kinks in the cable, as these can damage the conductors inside and reduce the ampacity of the cable. Follow the manufacturer's recommendations for minimum bending radius and support the cable properly to prevent damage. Metal-clad cable is often used in commercial and industrial applications due to its durability and resistance to physical damage. It is commonly used for wiring lighting fixtures, receptacles, and other electrical equipment in these environments. Metal-clad cable is also suitable for use in hazardous locations, where there is a risk of explosion or fire. When installing metal-clad cable in hazardous locations, it is important to use cable and fittings that are specifically rated for use in these environments. These cables and fittings are designed to prevent the ignition of flammable gases or vapors. Regular maintenance and inspection of metal-clad cable installations are essential for ensuring their continued safety and reliability. Check the cable for signs of damage such as cuts, abrasions, or corrosion, and repair or replace any damaged cable immediately. Also, check the connectors for tightness and corrosion, and tighten or replace any loose or corroded connectors. By following these guidelines, you can ensure that your metal-clad cable installations are safe, reliable, and code compliant. And remember to consult with a qualified electrician for any electrical work or concerns.